assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this question, we are told about an ice cube of mass 9 grams. The mass of ice cube is 9 grams. I was added to a cup of coffee. And the initial temperature of a coffee, so temperature of coffee is 90 degrees Celsius. And the cup contains 120 grams of liquid. So mass of coffee is 120 grams. So assume the specific heat capacity of coffee is that of water. So C coffee is 4.184 joules gram degrees Celsius. The heat of fusion of ice is delta H of fusion ice is 6.0 kilojoules per mole. Find the temperature of the coffee after the ice melts. So heat lost by coffee is heat gained by ice. Okay, so heat lost by coffee is negative mass of coffee multiplied by specific heat capacity of coffee multiplied by delta T, which will be the final temperature of the mixture minus the initial temperature of coffee, which is 90.0 degrees Celsius, is equals to heat gained by ice. And that is the mass of ice, that's 9.0 grams, multiplied by specific heat capacity of ice, C ice, multiplied by T final minus initial temperature of ice. We can assume that to be 0 degrees Celsius. So the delta H of fusion has been given to us, so we don't really have to trouble ourselves too much. And that is just when you have ice, solid water going to liquid water, H2O liquid. And that is for 1 mole. But we have 9.0 grams, so that is if we convert this to mole, that is 0.5 mole. And the heat of this reaction, then we need to multiply by 6.0. So that means that Q for melting the ice will be 6.0 kilojoule per mole times 0.5 mole. And this will give us 3.0 kilojoules. Okay, so knowing this, it's going to be very easy for us to calculate delta T, because we know that this as a whole should give us this value, or we can say this as a whole should give us this value as well, but it's just going to be the positive 10. So what do we do? What to do would be to say that so we can just go ahead and say this is going to be the mass of coffee is 120 minus 120 times its capacity of coffee, 4.184, times TF minus 90.0 is equals to 9.0 gram multiplied by its capacity of ice multiplied by TF minus 0 degrees Celsius is equals to 3.0 kilojoules. So we can take any of these two and equate them to 3.0. So it's better to take this. So if we take this, so say minus 120 times 4.184 times TF minus 90.0 is equals to 3.0. We can convert this to joules because it's in joules, times 10 raised to the power 3 joules. Therefore, TF minus 90.0 will be equals to 3.0 times 10 raised to the power 3 divided by 120 times 4.184 joules. That will give us I'll give us 5.98 degrees Celsius. But then we have to remember this is going to carry negative because of this negative sign. We should put that negative. So going to the next page, TF minus 90.0 is equals to minus 5.98. So TF then will be minus 5.98 plus 90, and that will give us 84.02 degrees Celsius. So that will be the final temperature. So we are told to find the temperature after the ice melts. But at this point, we have 9.0 gram of water at 0 degrees Celsius and 120 gram of coffee at 84 degrees Celsius. Therefore, the final equilibrium will be the temperature at equilibrium. Temperature at equilibrium will be mass of ice multiplied by the temperature of ice plus mass of coffee multiplied by temperature of coffee divided by mass of ice plus mass of coffee. So this will give us 9.0 times 0 plus 120 times 84 over 9 plus 120. And that will give us what? That will give us 78.1 degrees Celsius.